Hey guys, welcome back. This video, we're going to have a look at modules in Python and virtual environments. Let's start with virtual environments. So when programming in Python, different applications or programs that you make may use conflicting versions of Python or conflicting packages. A virtual environment allows you to specify a particular version of Python as well as a number of extra modules. It's good practice to set up a new virtual environment in the directory of every new lab or project that you work on. So let's start by installing pip, which is a package management tool. This allows us to install any modules that we may need which aren't in the standard library. The command for this is sudo apt install python3-pip. Great, so pip's been installed. You can use pip to install a number of packages using the command pip3 install and then the name of the package. Now, using pip, we're going to install the package which allows us to create virtual environments, which is called virtual env. So now virtual env has been installed, we'll make a new directory for our project. And we'll cd into this directory. Now that we're inside the directory, we'll create a virtual environment inside. So the command for this is virtual env, and then -- python, and you can specify a version of Python. So I'm going to choose Python 3. And finally, you give a name for the virtual environment. So I'll call this one venv. Typing ls, we can see that a virtual environment now exists inside this directory. Finally, we're going to activate the virtual environment by typing dot and then venv, or the name of your virtual environment, /bin/activate. Which means we are now inside the virtual environment and can install any of the packages that are needed for this project. So I can install a package inside the environment using the pip3 command we saw earlier. An example of a module is NumPy, which is often used for scientific computing with Python. So I can install this using pip3 install NumPy. Great, so we've installed a package. By typing pip3 freeze, we can see a list of packages and the versions that we have inside our virtual environment. So I have NumPy installed. Note that since we installed it while inside the virtual environment, it won't be accessible once we deactivate the virtual environment. I can deactivate the virtual environment by typing deactivate. Great, so that's how you set up a virtual environment. Next, we're going to have a look at modules. A module is a way of logically organizing your Python code and grouping related code in one place. Modules are good because they make code easier to understand and use, as well as reuse elsewhere. We can write our own modules, as modules are simply files consisting of Python code. These files can define functions, variables, and classes. I'm going to make two files to demonstrate this. I'll call them helper.py and markscalculator.py. I'm going to define some functions inside helper.py and then call these functions in markscalculator.py. In helper, I'm going to define a function getMarks, which will return a list of marks, and then another function average, which takes in a list of numbers and returns the average of these numbers. I'll then import and call these functions in markscalculator.py. So in helper.py, we'll define the first function, which returns a list of marks. I'm just going to return a random list of some sample marks data. And I've defined a second function called average, which takes in a list of numbers and then takes the average of them and returns this average. I can now import these helper functions in markscalculator.py using the import keyword. This import keyword is similar to #include in C. So the syntax for this is from, and then the name of the other module, which is helper, import, and then list the names of the functions or classes which you want to import from the module. In this case, I want to import getMarks and average. I can now call these functions inside this file. So I'll do marks equals getMarks. Pass these marks into the average function to get the average, and print the result. Let's run this to see the result. Great, so it's printed out the average. To import everything from a module, rather than specifying a list of the function names, you can use an asterisk. So I can write from helper import star to get everything from the module. Another way of doing this is to simply write import helper rather than from helper import and what I want to import. Using this method, I need to prefix all the functions from this module with the name of the module. So I'll write helper.getMarks and helper.average so that the program knows where to find these functions. This method of importing is useful when importing many modules to avoid conflicting function names. Running this again, you can see it gives us the same output. Great, so we've taken a look at how we can make our own modules and import them from other files. There are also built-in modules in Python which have library functions and classes that you can import and use in your Python programs. Some examples of commonly used built-in modules are math, which is used for mathematical calculations, random, which is used for generating random numbers, OS, which provides an interface for using operating system functionality, such as opening files, changing directories, or accessing environment variables, and sys, which is used for system-specific parameters and functions, such as using argv to get the list of command line arguments passed into the Python script. We can import these modules just like the custom modules we saw earlier. For example, I can import the math module, and this module has a function that lets us take the square root of a number. For example, I can say x equals math.square root of 16 and print x. Running this file, we can see it's correctly given us 4. It can often be useful to look at the Python documentation online to know what modules and functions are available. So we can see here the math module has a number of different functions, and you can see what their arguments are and what they return. Okay, so we've had a look at package management with pip, virtual environments, and modules. That's all for this video. Thanks for watching.